Adding and subtracting rational expressions. Now, when we worked on multiplying and dividing rational expressions, just like with fractions, all you have to do is multiply across the top, or multiply the numerators, and then multiply across the bottom, which is multiplying the denominators. For dividing, we had to make sure to flip the second fraction, or the second rational expression, upside down before we multiplied. For adding or subtracting fractions, or rational expressions as well, we have to make sure that we have the same denominator. We can't just add them up together right away. They have to have the same denominator. So step one will be to determine a common denominator. So we want to determine a common multiple of both denominators that we can convert both of them into. Now, the smaller the denominator, the better. If we do choose a larger denominator, that's okay. It will still work, but we'll have to reduce our final answer. So it's just better to have the smallest one if possible. So what we need to do after we determine that common denominator is to figure out what we need to multiply the denominator by in order to get your common denominator. So as an example, using fractions here, 5 and 4 are my denominators, so a common multiple between 5 and 4 is 20. So to convert 2 over 5 to have a denominator of 20, I'd have to multiply 5 by 4 to get 20. Now, it could be a number, a variable, a binomial, or anything like that, as we'll see for rational expressions. But what we have to be careful of, we have to multiply the numerator by the same thing. So right now, if I put 2 over 20, that's not the same thing as 2 over 5. It's a different fraction. So what I have to do is also multiply the numerator by 4. So I get 8 over 20. That is an equivalent fraction for 2 over 5. So that's good. So I want to add to that 3 over 4. So I'd have to multiply 4 by 5 to get the common denominator of 20. So that means the numerator is also multiplied by 5. So 15 over 20. Now, adding those up, we get 23 over 20. Now, I'm not going to worry about right now putting that into a mixed fraction. Improper fractions are okay for now. But I am going to check to see if I can reduce this. But there is no number that can divide 23 and 20, so I'm going to have to leave it like this. Alright, so putting this to use for rational expressions. So x minus y over 12x to the power 6 plus x plus 3y over 12x to the power 6. We want to put those together, and we also want to state our restrictions at the end. Now, first thing I check for is, do I have a common denominator? Well, I do in fact have a common denominator for this problem, so that's going to save me a lot of work. So what I can do is, I can actually write this as one large expression with the same denominator, 12x to the power 6, and my numerator is going to look like this. I'm going to have x minus y plus x plus 3y. So this plus sign, I'm adding together these two polynomials together. I'm adding up the two numerators. So nothing's going to happen to the signs because I'm adding. The signs stay the same. So I'm going to have x plus x is 2x. Then I have negative y plus 3y is plus 2y over 12x to the power 6. So I've added together the two expressions, but I'm looking at this and I think I can reduce it a little bit. So if I factor out a 2 out of the numerator, I've common factored it, just like we're simplifying in our previous lesson. I can also common factor out a 2 out of the denominator, and those will divide out, and we get our final answer of x plus y over 6x to the power 6. Alright, so whenever you do add up your expressions, always take a look at it and see if you can simplify it even further. Just like with fractions, we want it in lowest terms. Now, in terms of the restrictions, in this case, going through all of my steps, I have x to the power 6 as a common factor in all my steps, so the only restriction that I have is x cannot be equal to 0. In this example here, we have three rational expressions we want to combine, adding the first two and then subtracting the third one. And they all have different denominators, 4, 8, and 6. So I can't just add and subtract these just yet. I can't combine those polynomials. We have to make sure we have a common denominator. So what I'm going to look for here common multiples between 4, 8, and 6, a common multiple of all of those is 24. So if I want to turn the first expression to have a denominator of 24, I'd have to multiply the denominator by 6. And that means that I would have to do the same thing, multiply by 6 in the numerator. So what I get here is 6 times 3x plus 2. The whole numerator gets multiplied. So that would become 18x plus 12. The second expression here, I'd have to multiply this denominator by 3. So again, the numerator gets multiplied by 3 as well. So if my denominator is 24, my numerator now becomes 3x minus 12. I'm subtracting the last expression, and again, if I want a denominator of 24, I'd have to multiply this by 4. So multiplying the numerator by 4, I will get 8x minus 4. Now, you don't have to write this if you're having common denominators. You don't have to write them as separate expressions anymore. You can write it as one large expression as well if you like. But just let me know in class and I'll take a look at how you're doing it. So here I am going to combine everything together. So paying attention to the signs here, I have 18x plus 3x minus 8x. So 18x plus 3x is 21x minus 8x, I have 13x. Then I have 12 plus negative 12, that would be 0, minus, and this is a negative 4. So you have to be careful. Remember, if you're subtracting, the signs become the opposite. That would be plus 4. Now, looking at my final expression here, I'm going to check to see if it can be simplified, but there's no common factor for the numerator, so I cannot reduce that at all. Now, in terms of restrictions, I only have numbers. I only have 24, 6, 8, and 4 in my denominator, so there's no way that the denominator could ever be 0, and that is my final answer.